All right, let's walk through the cardiac cycle. So what we're going to do in the cardiac cycle is we're going to take everything that we've learned from heart sounds, from the electrical signaling in an EKG, from blood and how it's flowing through the heart, and we're going to put it all together in one giant image. So let me show you the picture we're going to be using. This picture. This is a picture that if you saw this in your book, you would go, oh, that's too complicated, and probably skip it. This picture, we're going to go through every one of these different parts of this diagram and talk about what they mean. So this collectively together is the cardiac cycle. And again, we are going to look at down here at the bottom, this is blood flow through the cardiac cycle. This is volume of blood in the ventricle. This is the pressure in different areas. And at the top is the EKG. So we're taking all the things we've talked about and putting it all together. So let's go back. The first thing that I want to walk you through though, is when we talk about the cardiac cycle, this is what is happening during one heartbeat, okay? During one complete heartbeat. And what we mean by that is atrial systole and diastole, followed by ventricular systole and diastole. What does that mean? The term systole means contraction. The term diastole means relaxation. So we are looking at the atria contracting and relaxing, and the ventricles contracting and relaxing. That is what the cardiac cycle looks at. It looks at one of those. Atria contract, relax, ventricles contract, relax. All right. So we are going to walk through the cardiac cycle, and your book kind of divides it up into phases. Okay, so the first phase of the cardiac cycle is what we call ventricular filling. This is exactly what it sounds like it is. The ventricles are filling up with blood. Okay. Now, in order for ventricles to fill up with blood, I want you to think of heart anatomy. This means that the AV valves, the ones between the atria and ventricles, those have to be open. Because think about how blood is flowing. It's flowing from atria down into the ventricles. So the AV valves are open. 80% of the blood that moves down into the ventricles is going to flow into the ventricles passively. That means there's no contraction that's getting the blood down into the ventricles. So 80% of that blood is just flowing from atria down to ventricles, and it's just following gravity, okay? The atria are going to contract. So this says atrial systole occurs. Remember, the term systole means contraction. So the atria contract. They're going to squeeze the other 20% of blood down into the ventricles. And then at that point, what we say is that the ventricles are as full as they will get. And we call that the end diastolic volume. Let's think about that term. Diastolic, or that term diastolic means relaxation, right? So the ventricles at this point, they're relaxed while the ventricles are filling up. That would make sense, right? They're nice and relaxed. So at the end of that relaxation period, the ventricles should be as full as they can possibly be. So that's why we call this the end diastolic volume, okay? So again, 80% of the blood is just flowing into the ventricle. The atria squeeze the other 20% into the ventricle, and now the ventricle is nice and full. End diastolic volume. Let's look at this in just this part of the cardiac cycle picture. Okay, we are looking just right here, just at this first phase. Okay, so over here, everything to the left of that line I just drew. So what we see is blood is moving from the atria to the ventricles. Okay, this is ventricular filling. Again, 80% moves in just passively. Then they're trying to show you here, see the arrows? They're trying to show you that the atria are contracting. Okay, so the atria is squeezed, you can see those arrows, and put the other 20% of the blood down into the ventricles. Now the ventricles are full. They are filled with blood. End diastolic volume. Now let's add it to this graph. Okay, so again, we just looked at it down here, okay, everything to the left of this line, and I'm going to draw the line all the way up. So it's everything to the left of that black line I just drew. Okay, so everything left of here. This is the ventricular filling phase. Okay, so we just walked through this very bottom image, what's happening with blood flow. Now let's look at this one, ventricular volume. Okay. You can see if you follow that black line, and put a different color on there, you can see that the amount of blood, ventricular volume means amount of blood. You can see the amount of blood is increasing in the ventricle, increasing, going up, going up. And then you kind of notice, let me erase that so that it's not on top of there. You kind of notice right here, I'll circle it. Do you see how it looks like there's a little notch right there? And then the amount of blood goes up even higher. What's happening at that notch? Yeah, the atria are contracting. So remember, 80% of the blood's flowing in passively. And then you can see right here, this little notch, the atria squeeze, and they get the other 20% of the blood in and fill up the ventricle. And when we're at this top part right here, we call that the end diastolic volume. Now let's look at this next graph, which is looking at pressure. Okay, now each of these different colored lines represent a different area of the heart. We're just going to look at the purple line, okay, for now. So the purple line is representing the atria. So if we look at the atria, follow that purple line, the atria, there's no pressure in the atria, no pressure, and then suddenly you can see a little blip in pressure. What's happening? Atria are contracting. Okay, so you can see that's why the pressure in the atria goes up. They're squeezing. And then if we look at the very top and put all that together, let's look at the EKG. What you see here is around the same time that the atria squeeze and pump the rest of the blood in, you can see the pressure in the atria go up when they squeeze. What are you looking at on the EKG? What wave do you see? The P wave. Why? What does the P wave represent? Atrial contraction. Okay, so we just took all these and put them together in that very first phase, which is basically blood moving from atria to ventricles, atria squeeze the rest of the blood in. Okay, and we are looking at what's happening volume, pressure, and EKG wise. Does that make sense? That's just the first part. Okay, now let's look at what happens next. Okay, so now ventricles are nice and full. So the next phase is called ventricular systole. Remember, the term systole means contraction. So at this point, the ventricles are going to start to contract. And as the ventricles start to contract, the pressure inside that ventricle starts to go up. Think of a water balloon, right? If you had a water balloon and you tried to squeeze it, the pressure inside that balloon starts rising. This is going to cause those AV valves to shut. Again, it's like a door. So as soon as the ventricles start squeezing, those AV valves shut close. The reason is we do not want blood to flow backwards into the atria. Okay, so AV valves close. And at this point, all the valves are closed. AV valves are closed and semilunar valves are closed. They're not open yet. And we call this the isovolumetric contraction phase. Ventricles are contracting, but the blood can't go anywhere because all the valves are shut. So this is why we call it isovolumetric. Remember, iso means same. Volumetric is volume. So the blood's not going anywhere. So we are still sitting at end diastolic volume. Ventricles are still super full and they're just squeezing. And then what's going to happen is as the ventricle keeps on contracting, the pressure keeps going up and up and up until eventually the semilunar valves open. The way I think of this, so we bought for my son those bunch of balloons. Have you all ever used those? Okay, so those have like, instead of tying the balloon at the end, they have these little like clear plastic, I don't know what they're called. They're like little washers at the end that hold it shut. And so my son has learned that instead of throwing the water balloon, he can hold it and he can point the end towards you. And if he squeezes hard enough, that little clear plastic thing will pop off. And now he has like a hose that he can squeeze at you, right? That in my mind is what I always think about when I think about this ejection phase. So you've got this ventricle that is squeezing until eventually that semilunar valve pops open and the blood can get ejected, okay? And once that blood is gone, we say it's called the end systolic volume. So remember, think of the word systole, means ventricular contraction. So at the end of ventricular contraction, there should be no blood left in the ventricle. It should have squeezed it all out. So it's the volume of blood that's left in the ventricle after systole, which is not going to be much. So let's look at this on this graph. Okay, so now we're looking at ventricular systole, which is all of this in the middle. And I'm going to draw my line up here and up here, okay? So we're looking at this second phase in between my red lines right there. So again, it's called ventricular systole, which means the ventricles are contracting. So let's walk through again the picture at the bottom. So what we see is the ventricles start to squeeze, and as they start to squeeze, remember the AV valves are going to shut. Okay, so those are going to close. But remember, the semilunar valves are already closed. So this is what we call the isovolumetric contraction phase, right? Iso means same, volume. The ventricles are squeezing, but the blood can't go anywhere. Until eventually, the ventricles squeeze so hard that those semilunar valves pop open and the blood can get ejected, right, out those large vessels, those large arteries. And we call that ventricular ejection. Both of those are found in ventricular systole. Okay? Ventricles are squeezing during both of those. Now let's look at volume. Okay, so during the isovolumetric phase, notice we're still at end diastolic volume. And that should make sense, right? Because AV valves and semilunar valves are closed, that blood's not going anywhere, right? So we're still at end diastolic volume. Here, once those semilunar valves pop open, look what happens to the volume of blood in the ventricles. Whoop, it goes way down because we're ejecting the blood out. And remember at the bottom, we call that the end systolic volume. That's the amount of blood left in the ventricle after the ventricle has squeezed it out. Now let's look at pressure. What's happening with pressure? This time we're going to look at the blue line, and the blue line is showing you pressure in the ventricle. So notice that the pressure in that ventricle, as it squeezes, the pressure in that ventricle is going up, 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 right? Because it is squeezing that blood out. Think of squeezing a water balloon, increasing that pressure. And then lastly, let's look at the EKG at the top, okay? We start with that wave right there. And what is the QRS wave? It's giant. What is it representing? If the P wave represents the atria contracting, what's the QRS wave representing? The ventricle is contracting, right? So all of those go together, okay? So again, ventricles start to contract, AV valves close, semilunar valves are already closed, that's isovolumetric contraction. Ventricles squeeze hard enough to pop open the semilunar valves and blood gets ejected. And here we can see the blood being ejected. Here we can see the pressure in the ventricle going up as it's squeezing. And at the top we can see the EKG, which is showing us contraction of the ventricle. Okay, so all put together. Now the last phase of the cardiac cycle, it's called isovolumetric relaxation. Now, we already talked about iso means same. So this is, the ventricles have now squeezed out all their blood. Now the next part is they're gonna relax back out again. The ventricles start to relax. But during the time that they're relaxing, as soon as they start to relax, the semilunar valves are gonna close. They're gonna close because we don't want blood to go backwards into the ventricle as it relaxes. So semilunar valves snap shut. And one of the things that we're gonna see on that cardiac cycle graph is something called the dicrotic notch. And this is basically showing you a rise in pressure off the aorta when the blood comes backwards and crashes against the semilunar valve. Because remember, there's a lot of pressure in that system, especially leaving that left ventricle out through the aorta. During this time, AV valves are still closed. Semilunar valves snap shut to prevent backflow. And so during this time, the ventricles, as they start to relax, they're totally closed chambers. So there's no blood coming into the ventricles. Eventually, what's going to happen is the pressure in the atria keeps going up because they're still filling with blood, and the AV valves are going to open, and the blood's going to start to come into the ventricle again. Okay? And the ventricles will start filling, and we'll start back at step one. So this is our third phase, which is right here. Okay, this is isovolumetric. And this one, and I'm going to draw my line up here. It is this in between my red lines right here. That's it. So again, remember, we just ended here where the ventricles have pumped out all their blood. They squeezed it all out. And now during this phase, they're going to relax. And as they start to relax, those semilunar valves snap shut so that blood doesn't flow backwards. But remember, AV valves are still closed. So the ventricles are once again closed chambers. This time they're empty closed chambers. That's why we call this one isovolumetric relaxation. You can see the volume is still end systolic volume. The volume in the ventricle is not changing during this time because it's a closed chamber, so it's still empty. And then up here, if we look at pressure, the ventricle is relaxing. So if you look at the blue line, you can see it is still coming down because the ventricle is relaxing. But I want you to see the green line, that's the aorta, and you can see the dicrotic notch at the top. So this is when the semilunar valve shut and the blood bounces off the semilunar valve in the aorta. You get this rise in pressure right here. And then lastly, I might have to erase my little line right here so you can see better. Lastly, at the very top, here is that T wave. So P, QRS, and T waves. P is atria contract. QRS is ventricles contract. T wave is ventricles are relaxing back out. So those all go together. Okay, so you can see ventricles are relaxing, all the valves are shut. Because it's a closed chamber, the volume is still empty. Okay, pressure in the ventricle is dropping, and you can see that T wave represents the ventricles relaxing back out. Now I mentioned that eventually the atria are still filling up with blood. And so eventually the pressure in the atria is going to get high enough that the AV valves will open and we come all the way back to the beginning. So we're all the way back to ventricular filling. So now AV valves are open. We're filling our ventricles with blood, 80% passively. Atria contract, fill in the other 20%. Ventricles start to contract and it snaps the AV valves closed. They're completely closed chambers. We call this isovolumetric contraction. They're full and they're starting to squeeze. Think of squeezing that water balloon. It's going to cause the semilunar valves to pop open. We're going to eject that blood. Ventricles are going to then start to relax back out after they've ejected all their blood. Semilunar valves close. They are completely closed chambers and we call it isovolumetric relaxation. Eventually, AV valves open and we start back with filling again. So this is just a cycle, okay? So there are 3 phases in that cardiac cycle that I walked you through. Ventricular filling is here while they're filling with blood. Ventricular systole, which means the ventricles are squeezing, which is here. And then relaxation, isovolumetric relaxation. The ventricles are relaxing, but they're closed chambers, okay? So it's a big, big graph that puts everything together. Can you all think of, oops, I have a couple chat questions. Let me see. Can you go over when the semilunar valves shut? Okay, so the semilunar valves, that was Aisha's question. So the semilunar valves, you can see here in the second phase in ventricular systole, the semilunar valves are open because the ventricles are squeezing the blood out, okay? As soon as the ventricle starts to relax back out again, the semilunar valves are gonna shut because we don't want blood to flow backwards into the ventricles. I want you to think of all the valves in the heart, their whole function is to prevent backflow into a chamber, right? AV valves prevent backflow, so the valves here, they're preventing the backflow of blood into the atria, and the semilunar valves are preventing backflow of blood into the ventricles. So when the ventricle starts to relax, that's when the semilunar valves are going to shut because we don't want blood flowing backwards into them, okay?